one of ways is solve this problem to change the structure to multi-layered or gradient. And the advantages of multi-layered gradient coatings compared with single-layer coatings are low residual stresses, fine dispersed structure, and high hardness, high wear resistance, high adhesions, and other improved properties. We can deposit multi-layered coatings with metal nitride type, where the metal and metal nitride alternating layers with thickness from units nanometers to hundreds nanometers. And you can see examples titanium nitride multi-layered coatings. And we can deposit gradient coatings with changeable elemental composition from substrate to upper boundary of coatings. In this report, we change the concentration of nitrogen from substrate to upper boundary. And methods of nitrogen concentration or phase compositions change in nitride coatings are change of composition or pressure of working gas mixture, energy change for ion delivery to a substrate, change of substrate temperature, change of arc discharge of metal plasma source, or use of additional source. For example, electron, ion, or plasma sources. And formation methods of nitrogen gradient and multi-layer coatings of metal nitride type are, at first, it's conventional method by change of partial pressure of nitrogen, or second method is change of parameters of additional source. But it should be known that the first conventional method is high inertial method, and time for pressure stabilization is reached up to 10 seconds. But second method is less inertial method. In our earlier work, we showed that the use of additional gas plasma source based on non-self-sustained arc discharge with thermionic and hollow cathode, with the use of this gas plasma source, we can change the concentration of nitrogen in nitride coatings. And if we increase the arc current of gas plasma source, the plasma concentration of gas plasma increased linearly. In the case of simultaneously used arc evaporator and gas plasma source at constant current of arc evaporator, we can increase plasma concentration of metal gas plasma at increase of current of gas discharge source, and it's explained by the increase of gas-ion share. And with increase of nitrogen ion share, we can increase the concentration of nitrogen in nitride coatings. There are two examples: titanium nitride coatings and molybdenum nitride coatings showed that effect. When we increase the concentration of nitrogen in coatings, the hardness increased, where parameters decreased. And we can observe the decrease of size of crystallites in coatings. All experiments were carried out on experimental automated ion plasma setup Quinta, and the main devices are arc evaporator with magnetic filter, arc evaporator with enhanced cooling system, and gas plasma source based on non-self-sustained arc discharge with thermionic and halo cathode of extended construction. And it should be noted that current of arc discharge with metal cathode was constant. The partial nitrogen pressure was constant, about 0.01 or 0.04 Pascal. The total pressure of argon-nitrogen mixture was 0.2 Pascal. And the concentration of nitrogen through a multilayered or gradient coatings thickness was controlled only by the ion current density of gas plasma source with thermionic and halo cathode in the range of 0 to 3 milliamperes per square centimeters. In both the cases, the discharge current of a gas plasma source was changed stepwise. And let's start with examples of multi-layer coatings with structure with metal nitride layered structure deposited by vacuum arc plasma assisted deposition. You can see a multi-layered structure on the scanning electron microscope images, and niobium nitride coatings have high hardness up to 51.5 gigapascal, and high elastic recovery up to 66%. Respectively low friction coefficient and very low wear rate in order 10 in -7 degrees. And by the X-ray diffraction analysis, we showed that the multi-layered coatings have next phases. Niobium nitride with cubic crystal lattice niobium, niobium 2 nitride. But the coating have only 5.5 volume percent of niobium phase. It means that in metal layer, we have not only metal phase, but also nitride phase with lack of nitrogen. Detailed research by transmission electron microscope it showed that in metal layer consists of niobium and niobium 2 nitride, niobium 4 nitride 3 phase, and in nitride layers consist of niobium nitride phase. And the coatings have column structure. Height of column is in the range of 85 to 105 nanometers. Transverse size of columns is in the range 6 to 47 nanometers. The column consists of nano-sized crystallites from 3 to 10 nanometers. Okay, to conclude this part, I want to note that this only one examples of multi-layered systems of metal nitride type. And we can deposit these multi-layered coatings by plasma-assisted vacuum arc deposition, but it is problem to form the pure metal layer. The next system is gradient zirconium niobium nitride coatings deposited by vacuum arc method with plasma assistance. Okay, we change nitrogen ion current density and our gradient coatings have high hardness up to 40 gigapascal, high elastic recovery, low roughness, respectively low friction coefficient, but high wear rate. And the coatings consist of zirconium nitride, niobium nitride, and zirconium niobium nitride phases. By transmission electron microscope method in scanning mode, it was shown that the coatings has a gradient nitrogen concentration from the substrate to upper boundaries of coatings. It's change on 7 to 9 atomic percent. And coatings have a multi-layer structure due to rotation of samples holder, and we can observe the following phase: zirconium nitride, niobium nitride, zirconium 2 nitride, niobium 2 nitride crystallites. And crystallites formed into column and have nanometer sizes. Okay. The next can you help me? Next slide.
Что-то близко может быть. Да?
Okay, the next system of gradient coating is zirconium, niobium, aluminium nitride. And the gradient of concentration from substrate to upper boundary of coatings is from 20 atomic percent to 47 atomic percent.
Сейчас попробуем.
Coating of zirconium, niobium, aluminium nitride have high hardness, high elastic recovery, and very low wear rate, and we can use as wear resistant coatings. Okay, you can see concentration gradient and also multi-layered structure. Okay, and the chrysalides are formed into column also, and have nanometer sizes. Okay, and features of plasma-assisted PVD method for synthesis of nitrogen gradient coatings and multi-layer coatings of metal nitride type. There are low inertial method, less than 1 milliseconds. That is creation possibility of sharp border between layers of wet or controlled elemental gradient in coatings. Constant pressure and composition of working mixture of gases, constant discharge current of metal plasma source. We can use of modes with plasma assistance, and it's allow depositing coatings with nanocrystalline structure and high physical, mechanical, and tribological properties. But it's required to optimize the deposition mode at first partial pressure of nitrogen, and it's not possible to form pure metal layers in the nitride containing atmosphere, even at low pressure of nitrogen. About 0.01 Pascal. Thank you for your attention.